It just happened. The event every astronomer feared and hoped for finally occurred. 3IATLAS-A has done something no one expected. And inside NASA's monitoring rooms, that silence that usually follows a new detection didn't happen this time. Because what they saw on their instruments wasn't noise. It was movement, fast, clear, and deliberate. 3IATLAS, the interstellar visitor that entered our solar system months ago, has suddenly changed its path again. Not by a random push of solar radiation, not by a typical comet jet, but by an adjustment so sharp that it made the orbit models fail instantly. Every prediction line, every future coordinate that had been calculated for weeks went dark. And NASA had to rebuild the data from scratch. For context, 3IATLAS isn't just another rock. It's only the third confirmed interstellar object ever detected passing through our solar system. Before it came Oumuamua, then Borisov, both rare enough to make front-page news. But 3IATLAS is different. Different in how it moves, how it reflects light, and now, how it behaves. Up until this week, scientists believed the object was following a relatively stable, hyperbolic path. Nothing unusual, a foreign visitor speeding through, warming under sunlight, slowly releasing gas and dust. But then the latest tracking data from NASA's Deep Space Network showed something impossible. Its velocity vector changed direction, slightly but measurably, in a way that natural outgassing simply can't explain. The first to notice was a team at the Jet Propulsion Laboratory. They saw a minor deviation in the predicted arc and thought it was an instrument glitch. But when cross-checked with data from the European Space Agency's solar orbiter, the same pattern appeared. A pulse of acceleration, brief and distinct, right as the object passed near the heliocentric longitude of Mars. What caused it? That's the question no one can answer yet. The simplest guess would be a burst of material escaping from beneath the surface, the kind of thing comets do all the time. But here's the catch. 3IATLAS isn't releasing any visible tail in that direction. No dust plume, no thermal spike, no emission signature. The movement happened, but the cause is invisible. NASA's official statement so far remains cautious. They've confirmed the course adjustment, but haven't offered an explanation. Internally, however, the discussion is far more intense. Some researchers are wondering if 3IATLAS could be hollow, a lightweight structure that reacts differently to solar pressure. Others are exploring a much stranger possibility, that the object's internal material might be reacting to the sun's magnetic field. Meanwhile, telescopes around the world have turned toward the coordinates again, trying to confirm the new trajectory. The Subaru telescope in Hawaii, the Pan-STARRS array, and several amateur observatories in Chile and South Africa have all joined the watch. And what they're seeing adds another layer to the mystery. In the last 24 hours, the light curve, the brightness pattern of reflected sunlight, has changed rhythm. Instead of the smooth rotation expected from a tumbling rock, 3IATLAS is now flickering in irregular intervals, as if different surfaces are catching light unpredictably. To most viewers, that might sound minor, but for scientists, it's huge. Light variations tell you how an object spins, what shape it has, and even what material it's made of. And 3IATLAS's new flicker pattern suggests either it's shifting its rotation or something on its surface is actively changing. NASA's Deep Space Network logged the event at precisely 4:12 UTC. That's when their Doppler tracking received a faint but consistent delay, a sign that the object had moved off its projected line by several hundred kilometers. The adjustment wasn't dramatic, but for a rock tens of millions of kilometers away, it was enough to rewrite the trajectory models. If you think this sounds familiar, it's because it happened once before, with Oumuamua in 2017. That object also changed course slightly without any visible reason, prompting theories from natural ice venting all the way to artificial propulsion. At that time, Harvard astrophysicist Avi Loeb famously suggested it could be a fragment of alien technology. A claim dismissed by most, but never fully disproven. And now, with 3IATLAS showing similar behavior, the debate is back. Is 3IATLAS a comet behaving strangely? Or is it something else entirely? Something that's responding to sunlight in ways we don't understand. For now, NASA's official line is simple. We are observing an unexpected non-gravitational acceleration. Further analysis is underway. In other words, they don't know. But behind the scenes, research teams are running simulations day and night. And every few hours, new orbital solutions are uploaded to the Minor Planet Center. And in one of those solutions, the predicted exit path has shifted, suggesting that if the same acceleration continues, 3IATLAS could leave our solar system at a completely different angle than first expected. Let that sink in. An interstellar object that came from the darkness between the stars just changed its own escape route. No known natural force fits the data perfectly. Even the sunlight pressure model fails unless the object is built from something extraordinarily thin, like a sheet of reflective material hundreds of meters across, weighing less than a ton. That's not a rock. That's a structure. Is it coincidence? Maybe. But when you line up the facts, the flickering light, the silent acceleration, the stable direction change, the pattern becomes harder to dismiss. In the control rooms, the next challenge is keeping track. As 3IATLAS moves closer to the sun's glare, it's becoming harder to observe from Earth. In a few days, it will slip behind the sun entirely, vanishing from optical telescopes for weeks. That means these current observations might be the last clear look we get until it reappears on the other side. NASA has already scheduled monitoring sessions using the Parker Solar Probe and the Solar and Heliospheric Observatory. Both spacecraft might catch glimpses as it crosses the inner region. If they detect another sudden acceleration, even a small one, it could confirm that the movement wasn't random. And that's what everyone is waiting for. Because if the same shift happens twice, it means 3IATLAS is reacting to something or doing something repeatedly. That would make it not just a mystery, but a controlled system. In online research forums, the debate is already exploding. Some users argue that the acceleration is due to asymmetrical melting of ice. Others point to the spectral data, which shows no trace of typical comet gases. A few even suggest electromagnetic propulsion, though no one dares to say it officially. Whatever the cause, the numbers don't lie. A measurable change in speed and direction means energy came from somewhere, and that's what has NASA on edge tonight. At the Jet Propulsion Lab, one insider described the reaction simply. Half the room stared at the data, the other half just went quiet. For anyone following interstellar science, this is the most significant update since Oumuamua. Not because we've proven anything alien, but because nature itself is acting in a way we still can't define. 3IATLAS may simply be the messenger, a reminder that space still hides phenomena beyond our equations. As of this moment, the object is continuing its journey. Its light flicker is stabilizing again, its speed returning to normal. But the anomaly remains recorded. A line in NASA's data logs that will be studied for years. And now there's growing curiosity about what might happen when it reemerges from behind the sun. Some predict another deviation. Others think it will vanish from detection entirely, absorbed by the light, lost in the background noise. But if it appears again, slightly shifted, slightly brighter, it could rewrite the story of how we understand interstellar travel. So what happens next depends on the next few days of tracking. If the light flickers again, if the velocity changes once more, or if any instruments detect any radio signature near its path, the discussion around 3IATLAS could change completely. Because if 3IATLAS repeats its strange motion, then we're not looking at coincidence anymore.
We're looking at intent. For now, one thing is certain. Something moved in the silence of space, and the instruments that recorded it weren't wrong. This isn't just another comet story. It's the moment scientists realized we might still be missing a chapter in how the universe works. And the next observation window, just a few days away, might reveal whether 3I/ATLS is simply a wandering rock or something that came here with purpose. So stay ready, because whatever it is, it's moving again.